In this lesson, we're going to be discussing if-else statements. So our lesson objectives: learn how to construct if and if-else statements, then we're going to learn else-if statements, and then learn nested if statements. So there's a lot of ifs in our statements here, but after all, it's a very powerful tool. So let's get into it. So the if statement. The if statement is a way of controlling or allowing the compiler to pursue a certain decision. It's allowing the compiler to make a decision, which is very powerful because now, based on a certain context, the compiler can give a certain output. So this is the basic if statement. We have the if statement. That would have been weird if we had an if statement without the word if. But we have an if statement, and then in parentheses will be a Boolean expression. So it could be like x is greater than or equal to a certain number. And it could have the logical operators. It can have the relational operators. And basically, we have this Boolean expression to provide a context and allow the compiler to make a decision based on a Boolean expression. And if this Boolean expression evaluates to true, then the Java statements here get executed. But if this Boolean expression gets evaluated to false, then the Java statement here will not get executed. So just to sum it up, the Java statements will only execute if the Boolean expression evaluates to true. And it will be within these curly brackets. So we don't have a semicolon here. What we have is another set of curly brackets, and then within the curly brackets will be stuff like the print statement. So let's see practice question number 1. Now, I didn't put any variables here just to keep it simple, but I do have a compound Boolean expression, meaning that I have two Boolean expressions paired with an and operator. So we have an if statement, and we have a print statement that says the Boolean expression is true. So this is our Boolean expression. 5 is greater than 3. 5 is greater than 3. So that will evaluate to true. 9 is less than 21. 9 is less than 21. This operator over here tells us that both sides of the Boolean expression need to be true in order for the entire thing to return true. This side is true, and this side is true. So this entire thing evaluates to true. And if we know from our previous definition of the if statement, the only time the if statement will execute anything that's within the curly brackets is if the entire thing is true, which is true in this case. This entire thing evaluates to true, which means that this print statement gets executed. The Boolean expression is true. So it prints out the Boolean expression is true because we have the true statement, and the Java statements that are within the curly brackets will get executed. Now we have the if-else statement. The if-else statement allows us to make a decision, but if the decision or the context evaluates the false, if this Boolean expression evaluates the false, then the compiler has another thing to execute. So without the if statement, there is a possibility that nothing will get executed. But with an else statement, we're most likely guaranteeing a certain output every single time. So if the statement here evaluates the true, the compiler doesn't even look at the else statement. It doesn't look at it at all because this evaluates to true. So if that's true, then it will execute to this. But if this Boolean expression evaluates to false, then the compiler will execute what's in between within these curly brackets under else. So we have an if statement to say, hey, if this context is true, if this Boolean expression is true, then I want you to execute these Java statements. However, if this Boolean expression turns out to be false, then I want you to pursue the else statement. So if this is true, execute this. Else, I want you to execute this. So let's look at practice question number 2. Now we have integer x is equal to 20. We can get this integer by simply just writing integer x is equal to 20, or we can get an integer through our scanner class and get user input from the user. Anyway, for the example I have for this practice question, I have integer x where I declare integer x and I let x equal 20. So I'm assigning the value 20 to integer x. So it looks at the first if statement. If x is greater than 21, I want you to execute this print statement. So x is greater than 21. So it looks, what is x? X is 20. 20 is greater than 21. Is 20 greater than 21? No, that is false. So we know that in a false statement, the if statement does not get executed. But this is not an if statement, it's an if-else statement. So if this evaluates the false, then we have another thing that it executes. It executes the else statement. So if it's true, it will execute this. But since it's false, it doesn't look at the Java statements. It doesn't look what's in between these brackets and goes on to the else statement. And it prints out x is not greater than 21. Now we have an else if statement. Let's say if we want multiple Boolean expressions to evaluate before we reach the else statement. Well, we can do that with the else if statement. So it first does if Boolean expression and the Java statements here. Basically, what the compiler does is that it looks at this section first. It ignores anything after that for now and says, hey, I want to evaluate the Boolean expression. If the Boolean expression evaluates the true, it executes the Java statements in between these two brackets and doesn't even look at the else if statement and the else statement. Now, if the Boolean expression evaluates to false, then it moves on to else if. Now, else if will only execute if the Boolean expression evaluates the true. If it evaluates the true, then it executes everything in between these curly brackets, right? It doesn't look at this, it doesn't look at this. It only evaluates anything that's in between these brackets if this is true. Now, if this is also false, just like this is false, then it will execute the else statement. So in this scenario, even if both Boolean expressions evaluate to false, then the else statement will there to provide some output. Whereas if this Boolean expression with it next to the if statement evaluates to true, these Java statements get executed. If the else if Boolean expression evaluates to true, only if the if statement does not evaluate to true, this has to evaluate to false in order for this to get executed, to even have a chance of getting executed. If this is true, the compiler doesn't even look at these two things. This has to be false in order for the else if to even be evaluated. So if this is true, then these Java statements get executed. If it's false, then the compiler goes on to the next statement. And if we want multiple Boolean expressions, we simply just keep adding an else if we want that. And then we could finally end with an else if we want a compiler to always have something to resort to if all the Boolean expressions evaluate to false. So this is our practice question number 3. We have integer x is equal to 18. Integer x is equal to 18. So if x is greater than 19 and x is less than 25, it will print out x is greater than 19 and less than 25. All right, so let's go this by one. We declare an integer x is equal to 18. So it's 18 greater than 19. 18 is not greater than 19. And because of our short circuit evaluation, the compiler doesn't even look at this because it already knows that both sides have to be true, but one side is already false. So this entire thing has to be false. And even if we do look at this, even if this evaluates to true, which it does, this section does evaluate to true, this false statement makes the entire thing false because both sides need to be true. So this is a false statement, so this section gets crossed off. This if statement does not get executed. The Java statements in between this print statement is not going to get executed. So what the compiler does is that it goes on to the next one. Else if. We have an else if statement. X is greater than 19. X is greater than 19. 18 is greater than 19. 18 is not greater than 19. So this will evaluate to false. So this statement, this print statement, x is greater than 19, does not get evaluated. It does not get printed. Compiler doesn't even look at that because the Boolean expression here is false. So we have a false statement here and we have a false statement here. And when that occurs, we go on to the next one. We have an else if statement. X is less than 25. 18, since that's x, is less than 25. Is 18 less than 25? That is a true statement. If that is a true statement, that means that this gets executed in between the brackets. So the printer or the compiler will print out x is less than 25. And the compiler then ignores this else statement because we've already executed one of our else if statements, and this is all comes together. So if one of these gets executed, that means the else statement or anything after that does not get executed. And for us to even reach this else if statement here, this has to evaluate the false, this has to evaluate the false for it to even look at this else if statement. So that's why we reach this else if statement in the first place, because this evaluates the false and this evaluates the false. And that's also why the compiler ignores this, because this it was evaluated to be true, so it prints out this and ignores this. Now, nested if statements is basically putting an if statement within an if statement. So if we have a value like this, if a Boolean expression here, if Boolean expression 1 evaluates to true, then the compiler will go and execute whatever is in between these two brackets. And in between these two brackets is, well, another if statement. So in order for that to even execute, this Boolean expression number 2, has to evaluate to true. And if that evaluates to true, then the Java statements within the second if statement gets executed. Now, if the first statement gets evaluated to false, then it doesn't even look at this if statement, because it doesn't compile, or rather evaluate, or even execute anything that's in between these brackets, because this Boolean expression was evaluated to false. Now, if this was true, then what the compiler does is that it goes on to the if statement here. Now, if this evaluates to true, then it prints out or executes these Java statements. But if this executes to false, even if this is true, then it would not execute these Java statements. It's kind of like rewriting our if statement like this: Boolean expression 1 and Boolean expression 2. So both of these have to evaluate to true in order for the Java statements to execute. Kind of like how both of these have to evaluate to true in order for the Java statements here to get executed. So practice question number 4. All right, we're in practice question number 4. I know it's a pretty long lesson, but it's a very important lesson. So we declare an integer x is equal to 20. So if integer x is greater than 15, integer x is greater than 15. Well, we have integer x assessed or assigned as 20. So we put 20 here. 20 is greater than 15. Well, 20 is greater than 15. So what it does is that it compiles, or rather executes, anything that's in between the curly brackets for this if statement and ignores the else statement. All right, so then it looks at this. We have another if and else statement. And if x is less than 18, it prints out this statement. All right, if x is less than 18, well, 20 is less than 18. 20 is not less than 18. So it does not print out x is greater than 15 and less than 18. If x was 17, right, then it would execute, because this would be true and then this would be true. But this is only true and this is false. So it goes on to the else statement in between here, in between the if statement, because we're still within the if statement. Everything gets executed if it's in this if statement, because this was evaluated to true. And it executes this else statement. This x is greater than 15, because this was true, and 20 is, after all, greater than 15. So it pretty much tells the compiler, tells the user, that x was greater than 15. This Boolean expression was evaluated to true, because if it was evaluated to false, then it would print out x is less than 15. That would only occur if x was some number like maybe 14. So let's do some coding within our compiler. So the first program that I want to make is an odd versus even program. Basically, I want you to provide a user input, or rather let a user provide an integer, and then the compiler would tell it whether or not if it's even or an odd number. So if you want to try to make a program that tells the user if the number that they entered, or the integer that they entered, is a odd or an even number, go ahead. All right, so now I'm going to make the odd versus even program. So we first declare our class. Public class odd v even. Then we have our curly brackets, and everything will be in between there. Then we declare our main method, public static void main string arg. And then we have curly brackets for our main method as well. And then we're going to put our program or statements in here. So the first thing I want to do is allow the compiler to get some sort of user input. So before I use the scanner class to get user input, I need to import the scanner class. So we do that through the import statement, import java.util.scanner. That is a way of directly getting the scanner class or getting the scanner object to be put into the compiler, or we can just import all the classes that are inside this package by doing java.util.asterisk, and that will import all the packages so that other classes that we may use in the future lessons will be automatically imported. Alrighty, so let's declare our scanner object. Scanner, my scanner is equal to new scanner system.in. Alrighty, so we declared that we want a scanner object, so the computer or compiler is allocating some memory to store scanner within our computer, and then we actually create the scanner using this. Now we want to tell the user to enter a number, so we use the print statement, system.out.println, enter integer. Alrighty, now that the compiler tells the user that you should be entering an integer, we need a way of the compiler to actually get that integer into a variable. So we first declare the variable that we want to get from the user. So integer user number, or your user integer. And we set that equal to whatever our user input is. So we access my scanner so that the compiler knows that we're utilizing our scanner to get an integer. So we access the next int method of the myScanner class or myScanner object in order to get user input. So this is accessing the scanner, and this is telling the compiler that we want the user to enter an integer. Alrighty, so how do we tell, or how do we calculate whether or not a number is an odd versus even number? Well, if I know one thing, if it's an odd number, if we divide the number by 2, we should have a remainder over. Whereas if we have an even number, when we divide it by 2, it should be a relatively easy number to evaluate too. We would have a 0 remainder if we do modulus 2 on an even number. Whereas on an odd number, when we do modulus 2, we would have a remainder of 1. So we do that by creating another integer, maybe integer a or integer check is equal to whatever the user integer is, and then we do modulus 2. Then we create an if statement, and we check whether or not that if this is equal to 0. So if this is equal to 0, then it would be an even number, because even numbers, when we divide it by 2, shouldn't have a remainder. Whereas if we divide an odd number by 2, we should have a remainder of 1. So if check is equal to 0, then I want you to print your number is an even number. And then we have an else statement that if this gets evaluated to false, because most likely if check evaluates to 1, then we would have an odd number. So else, and then we have a print statement saying your number is an odd number. So essentially what I'm doing with this Boolean expression is that it checks whether or not if our modulus of 2 is equal to 0, because if it's equal to 0, then that will mean that it's an odd number, and if it's it's an even number, and if it's even number, then this entire thing gets evaluated true. Now we can completely avoid this step by simply just putting this within the Boolean expression. So what I'm going to do is I'm going to remove this and replace that check with user integer modulus 2, and it's going to check, all right, is user integer modulus 2, what does that evaluate to? So let's say if I put 5, if I do 5 modulus 2, then we should have a remainder of 1, because 2 fits into 5 2 times, and that should equal 4. 4 subtracted from 5 is a remainder of 1. So that does not equal 0. 1 does not equal 0. So that thing evaluates to false, and then this gets executed. So let's try it out. File, and let's save. Alrighty, I saved my file. Now I'm going to compile to see if there's any issues. There is no issue, and let's run. So let's enter an integer. An example of an integer that is an odd integer would be 5. And it tells me that your number is an odd number. So now let's see if the same holds true when we put an even number. And we put an even number like 4. And it tells me that your number is an even number, and that's simply all based on our modulus. So whereas 5, when we do modulus 2 with it, we get a remainder of 1. We get the remainder of 1 does not equal 0. 1 does not equal 0, so it prints out this else statement. But in the case of 4 modulus 2, well, we don't get a remainder with 4 modulus 2, because 2 fits into 4 perfectly like every other even number. So that evaluates to true, because 0 remainder 0 is equal to 0. So this statement gets executed because this is a true statement. So now for the second assignment, what I want you to do is create a program that gets user input from 3 integers, or gets user input of 3 integers, and then returns the biggest integer that the user provides. So you can pause the video and then try to do it, or you can watch me do the solution for that. So let's create a new Java file, and let's name it, well, let's first import the scanner class, because we know that we're going to get some user input, and we could do that through the scanner class. So I'm going to import the entire package utilizing that statement. Now let's declare the class, public class 3 integers. And then let's declare the main method, public static void main string args. And then everything that we do is going to be in between the main method. So because we're using a scanner to get user input, let's declare and make a scanner. So we declare the scanner. I'm going to name it my Fozon scanner, so that whenever we access it, we can use my name and then the scanner. This will allocate some memory so that we can store the scanner within our compiler. And then the actual action of creating the scanner is by calling it new scanner system.in. All right, so now we want to tell the user to input 3 integers, and we do that by 3 print statements. And then after those 3 print statements, or rather after each print statement, we're going to have an integer declaration that gets user input. So let's first declare our 3 print statements. Enter first integer. And I'm simply just going to copy and paste it 3 times to save me some time. Nope, I put it to 1 extra time. Alrighty, so enter our second integer, and then enter our third integer. And then after each of these print statements, I want to get user input in the form of an integer. So we declare an integer, integer number 1 is equal to, anything that we get from Foson scanner, and it has to be an integer input. Alrighty, and we do the same thing for every single one of these print statements, except we name or we change the identifier to have 3 different numbers. So instead of number 1, it's now number 2. Alrighty, so we have a print statement, we get a number. We tell the compiler, or tell the user, sorry, that we want another number, and then we get another number. And then we do that 3 times, and then we get a third number. Now we need to construct an algorithm that basically calculates which one of the 3 numbers is the biggest number. And we'll do that through nested if statements. So let's make a hypothetical scenario, or rather a hypothetical if statement that calculates whether or not number 1 is the greatest number. So we have an if statement that says if number 1 is greater than number 2, I want you to execute what's in between these brackets. Now we want to see if number 1 is also greater than number 3. So we put another if statement within that if statement. And then we have our curly brackets for that if statement as well. And then I want to print out that number 1 is greater than number 2. Greater than is the greatest number. So number 1 is the greatest number. Alrighty, so what I did with this if statement is basically find out whether or not number 1 is the greatest out of the 2 integers. So what it does first is says if number 1 is greater than number 2. If number 1 is greater than number 2, then it will execute what's in between these statements, because this Boolean expression will evaluate to true. So then it checks whether or not number 1 is greater than number 3. If number 1 is greater than number 3, that means that number 1 is greater than number 2, and it's greater than number 3. So then it executes number 1 is the greatest integer, because through this algorithm, we're basically indirectly saying, hey, number 1 is greater than number 2. That's true. And number 1 is greater than number 3. That's true. Alrighty, now that's in the scenario that number 1 is the greatest number. So now let's do that for number 2 and number 3. Now the reason why we're not doing an else if statement in this case is because, well, let me first finish this statement. If number 2 is greater than number 1, I want you to execute this another if statement. Now if number 2 is also greater than number 3, then I want you to print out number 2 is the greatest number. Now the reason why I'm using an if statement instead of an else if statement is because if this evaluates to true, but this evaluates to false, then it's not going to look at the else if statement here. But we want to find out which one of these is the greatest number. So if this gets executed, then it's not going to even look at the else if statement, even if this evaluates to false. So we want this to execute no matter what. We want to see if number 2 is in fact greater than number 1 and number 3. So we have this as an if statement. All right. And no matter what, we will only have, well, if we do the algorithm correctly, we should only have one output. So don't worry about that. If the algorithm works out, we should only have one output saying, hey, we want one number. All right. So let's change that to number 2. So the reasoning I have for number 2 is that if this evaluates the false and if this evaluates the false, then we're going to be looking at this if statement, and the compiler is going to be like, all right, is number 2 greater than number 1? All right, if number 2 is in fact greater than number 1, then I also want you to check within the statement, all right, if number 2 is also greater than number 3. And if that is true, then I want you to print out number 2 is the greatest number, because number 2 is greater than both number 1 and number 3. We reach this point because these two statements evaluate to true. Alrighty, now let's finally do that for number 3. So if number 3 is greater than number 1, then I also want you to check whether or not number 3 is greater than number 2. And if both of those become true, then I want you to print out number 3 is the greatest integer. And just like the reasoning that I said for both other algorithms or both other if statements, basically, in order for this to get executed, both of these Boolean expressions need to be true. So that means that number 3 has to be greater than number 1. Number 3 also has to be greater than number 2. So if both of these are true, then number 3 is the greatest number will get executed. Alrighty, so let's save the program and let's see if it works. I wouldn't, count on me having both a completely correct program right now, so let's see if this works. Probably forgot a semicolon somewhere. Alrighty, so let's compile. Alrighty, no problems with our syntax, and then run. Alrighty, let's enter our first integer. So let's do 56. Let's do 32. And then let's do 89. So 89 should be, in theory, our answer, right? It should print out 89 is the greatest number. And it prints out 89 is the greatest number because it goes through each algorithm one by one. So in this case, what it does is, all right, it assigns number 1 to be 56, assigns 32 to be number 2, and it assigns 89 to be number 3. So it looks, all right, is number 1 greater than number 2? Is 56 greater than 32? Yeah, it is. All right, so that's true. Let's go on to this if statement. Number 1 is greater than number 3. Is 56 greater than 89? Nah, so this print statement does not get executed. Alrighty, let's go on to the next if statement. Is number 2 greater than number 1? Is 32 greater than 56? No, it's not. So this if statement does not get executed at all. So this if statement does not get executed. In between these brackets, nothing happens. So in the previous example, this stage was evaluated to true, but this was evaluated to false, which prevented us from looking in here. Well, we're not even looking at an evaluation of this. The compiler doesn't even calculate whether or not number 2 is greater than number 3 because this is already false. And if this is already false, then it ignores anything that's in between these brackets. So then it goes on to the third major if statement. Is number 3 greater than number 1? Is 89 greater than 56? Yes, it is. 89 is greater than 56. All right, so that's true. So let's go on in between these brackets. So what's in between these brackets will get executed. All right, is number 3 greater than number 2? 89 is greater than 32. Oh, wow, we have both two true statements. Number 3 is greater than number 1. Number 3 is also greater than number 2. Therefore, number 3 is the greatest number. Or 89, which is number 3 in its variable form, is the greatest number. Alrighty, so that wraps up our video on if statements. It's a very powerful tool. We'll go more advanced in later videos, but for now, I think this is a pretty good introduction to control structures.